Hello calculus students and seekers of truth. In this video we will practice some problems with the quotient rule. And just for reference, this is the quotient rule. Given a function q equals to f over g, q prime is the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator all over the denominator squared. Okay, so let's practice. And let's look at number one. And oftentimes it is more helpful if we simplify and organize the problem first algebraically before we try to actually do the calculus. Okay, so in this case, I'm going to rearrange the top here. I'm going to call this, let's see, we can do this a bunch of different ways, but it's 3x, right? And then minus 3 over x, so I have a fraction within a fraction, and that's undesirable, so I'm going to multiply this first term here by x over x, so that's going to give me 3x squared over x, and then that will allow me to do a few things that allow me to combine these two fractions together. So that will give me 3x squared minus 3, all of this over x, and then all of that over x minus 5. But if you recall, dividing by something is the same thing as multiplying by its reciprocal. So you can think of it this way as well. Okay? So my original numerator is this. I put it together into this expression, and instead of dividing by x minus 5, I'm multiplying by the reciprocal. So let's go a few more steps. The numerator I have here is 3x squared minus 3, and the denominator that I have here is x. It's going to be x times x minus 5, or x squared minus 5x. Okay, and that makes things a little bit easier for me to work with. And I'm going to take this maybe one step further, because I can take out a 3 in the front here. So what I have left here is x squared minus 1, and all of this over x squared minus 5x. Okay. I can also factor out an x in the denominator, but that won't really help because when I go to take the derivative, I have to kind of multiply it back. But the constants are helpful. Okay, so this is my function f that I'm going to take the derivative of. So now I'm actually going to take its derivative. So f prime. So it's going to be the derivative. So I'm going to call the numerator here u and the denominator v. So f prime, and this is just my side note, is going to be u prime v minus v prime u, all of this over v squared. Okay, the derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared. All right. The 3 is a constant, so it kind of goes along with everything else. And then the real work happens here. So the derivative of the top, which is u, is just 2x, times the bottom, which is x squared minus 5x, minus the derivative of the bottom. Let me draw this a little bit better here. Okay, minus the derivative of the bottom, or v prime, is 2x minus 5 times the top, x squared minus 1. Okay. All right, so you can see how gnarly this can get. All of this over v squared. Okay. All right, and that's it. That's the derivative. Now, for good practice, we should also simplify as much as we reasonably can. So I still have the 3 in front. When I distribute all of this here in the numerator, and generally the denominator I leave alone, the numerator I'm going to get 2x cubed minus 10x squared. minus, when I distribute this out, I'm going to put a big parentheses here because I'm actually subtracting that whole thing. That's something that people often forget. That gives me 2x cubed. Then 5x squared. Negative 5x squared. Then negative 2x. And then positive 5. Okay. And then the denominator, I'm going to continue to leave that alone. Just like that. And then I go maybe one more step here just to clean up all those like terms here on the top. So this is, you notice here I have a 2x cubed. It's going to subtract another 2x cubed, so that's going to be gone. I have a negative 10x squared, and then I'm going to add 5x squared. So that's going to give me negative 5x squared. And then plus 2x. And minus 5. Okay. And all of that over x squared minus 5x quantity squared times, don't forget that 3 in the front. Okay. So this is the derivative of f of x. All right, so that's our first example here of using the quotient rule. And you see it's pretty messy. That the quotient rule is messy. There's no way getting around it. But it does work. It takes a bit of practice. Some of it can be tedious at times, but you got to have a lot of repetition with these types of problems to really get the hang of it and to avoid all those little errors. As always, thank you for watching. Keep working hard and ask for questions whenever you need it. Have a wonderful day.